Hello, everybody. My name is Jennifer Milne, and I lead product marketing here at Formlabs. Thank you for joining us for this panel discussion, the past, present, and future of Formlabs hardware engineering. So this particular panel, hello, Stephen, welcome, came together actually at the first Formlabs Digital Factory and User Summit event. We had this panel with different engineering leaders from across hardware, materials, and software. It was kind of a more candid and conversational question and answer session about our product, and we wanted to do something similar. So thank you to the team who put this event on for humoring me and letting us do this. I'm super excited to be joined by three fabulous engineering leaders from across Formlabs. Jake Misra, who leads sustaining engineering. Hi, Jake. Ian Ferguson, who is leading the Fuse One project and also a Formlabs veteran. You may have seen him in Print the Legend and his other movies. And Caitlin Rada, who has also been here a pretty long time, who you will know from much loved products, Form Wash and Cure, and also leading the Form 3L through to successfully starting shipping recently, which is super exciting. So this really is a panel session. We have no slides. And what we're going to do is talk about product design and development from kind of a high level about how we do that at Formlabs. We are a hardware technology company who are making hardware products. And at the same time, we also have this meta perspective with most of our customer base actually doing product design and development themselves. So this is an area that I'm personally super passionate about. Did a lot of my early education in interdisciplinary product development, and 3D printing is really a great industry to be in for that because, like I say, we're doing kind of hardware, materials, and software at the same time. So we're hoping that we have a lot of fellow mechanical engineers on the call or people who are nerdy about product design and development. And yeah, we're going to talk hardware. So I have some questions lined up that I think are interesting. Please weigh in the chat. Elise, my colleague, is going to help answer questions live so I don't get too distracted. And you can also submit questions through the Q&A app. Cool. So to get started, I would love for you guys to introduce yourselves. So could you kind of share maybe what you were doing before Formlabs, how long you've been part of the team, where you started out, what you're doing today, and yeah, any sort of quick highlight or product that you've worked on. So Jake, let's start with you.
Sure. Yeah, happy to start. So I've been with Formlabs for almost 4 years now. It'll be 4 years in January. I started out as a mechanical engineer in a sustaining engineering role, but it was quite a bit less defined when I joined the company. I actually reported into the systems integration group at the time, and then as the role grew, we actually formed a whole team around it. And so now I lead the sustaining engineering team. It's a mix of mechanical engineers, electrical engineers, and data analysts.
Awesome. And Caitlin, how about you?
Yeah, so I'm Caitlin Rada. I'm the program manager for the Form 3L. Before Formlabs, I was in grad school for mechanical engineering, and then I came straight to Formlabs. I started about 6 going on 7 years ago, right when we kicked off the Form 2 product development process. I started off as a mechanical design engineer for the Form 2. I worked on the resin cartridge system and the resin tank system, doing mechanical design. And then after that, I started working on the Form Wash and Form Cure, which are the post-processing products for our stereolithography line, and did more mechanical design for those. Also was involved in bringing those to our factory and really ramping those up for production. And then most recently, I've been leading the Form 3L program and making sure that we can deliver this product to our customers. And as Jenny mentioned, we just started shipping, which we're super excited about.
Thanks, Caitlin. And Ian.
Hi there. Yeah, so I've been at Formlabs coming up in December. I'll be here 9 years. So I've slowly forgotten what life was like before Formlabs. But I did briefly work on some at a toy company before, and grad school before that. Like everybody else here, the trend is I started with doing mechanical design all the way back on the Form 1, designing sheet metal and pieces like that. And over the years, my role has slowly evolved, working on the Form 2, doing more mechanical engineering, and then in leading washing cure systems. And now I lead the Fuse SLS system development, which is also getting quite close, and has been quite the journey. And yeah, we're really excited about where that's at today.
Cool. All right. Thanks, everyone. So yeah, very diverse background. One more thing I wanted to say is just to note that we, all have mechanical engineering backgrounds, but ended up in slightly different roles. So I would be remiss if not to plug that Formlabs is always hiring, and technical backgrounds are basically helpful in any part of the company. So also happy to take any questions about sort of career advice, or if you're kind of curious about different types of engineering, we can talk to that too. Cool. So Ian, as someone who was, pivotal in sort of the Form 1 days, can you talk a little bit about how engineering at Formlabs has changed as we've gone from a one product company to a multi-product company?
Yeah. So engineering has definitely evolved tremendously over the years from when I started. Needless to say, I think our greatest skill was naiveness, that we could just that we could do anything and get a working 3D printer out the door. Well, I don't know, in like a year. How hard could that be? And so the Form 1 was developed with a very, very small team. Certainly, in some ways, very insulated because we had no outward-facing customers yet. We could just kind of sit there and tinker on this sort of artisanal little SLA printer, which was great. And we always had ambitions for a mass-produced product and professional users who would really benefit from a really powerful product. But I think at the time we, as I said, naiveness was powerful because it could let us get going and build and prototype and ship and learn quickly, which was really, really great. But that feedback has come. It was very heavy in the Form 1 days, and has certainly been integrated into our product development process. So we now take a much more organized approach to product development, sort of in some ways more traditional in terms of how companies take products from sort of conceptual stages where we try to understand what customers are looking for. We now have the benefit of lots of users who can give us very clear and direct feedback about what they want in our products. And then we can sort of carry that feedback through a development process that translates that into designs and systems that will meet those goals, and then ultimately a more robust manufacturing and test process before these products actually go out into the world. And then as we have Jake here, also a process to then continue to support those products as they transition from pure development into products that are surviving and operating in the field, but still have room for improvement. So this process has definitely evolved a lot over the years. We also have far more engineers. When I started, we were 4 people in a room. Depending on how you count, like the Fuse printer that I spend my day-to-day on, we have about 40 engineers working on with a really diverse group. So we have more mechanical engineers working on the Fuse than we had total employees for almost the first year of my time at Formlabs, which is exciting and powerful. It means we can really do a lot more. The Fuse is a vastly more complicated and involved product, and we would never be able to do it with a much smaller team. But it also means we have to be more organized and thoughtful in how we get our work done.
Cool, great. So you talked a lot about more formal processes, kind of understandable as the company evolves, and we've maybe lost our naivety. Maybe we need more of that. I'm not sure. Cool, but you talked a little bit about sort of, with our first product, obviously we were kind of making it in a bubble, and then we released it to the world, and now there's more of a feedback loop to customers. So I thought that kind of segues nicely into some of the work that Jake's done. Jake, could you kind of just talk to, I know a lot of your roles have been about learning from our install base in terms of printer performance and feeding that back into product development. Could you kind of just talk to, just this more customer facing monitoring engineering that you do. It's kind of the phrases integration engineering and then sustaining engineering are kind of new to me. They're certainly not things I came across when I was in school. So can you kind of just explain, what those functions are?
Yeah, and I think that's a great place to start. I think so. At a high level, sustaining engineering generally is all of the engineering work that happens after you've introduced a product into a market. And so this includes the identification of issues and new features that your user base is asking for or needs, and then the implementation of those new features and fixes to issues, whether that's in manufacturing or in software. And so when you're a small company, you don't really need a dedicated sustaining engineering team. Like Ian was saying, when the company is less than 50 people, everyone is doing that work. You design the Form 1 and you know very clearly what your job is, make the best printer that you can, and then move that printer into production, and then see what the world thinks. And then the world is going to respond in some way. They're going to use the printer in ways that you didn't anticipate. It's going to fail in ways that you didn't anticipate. They're going to ask for things, whether that's new resins or new applications that you really weren't thinking about. And so that entire engineering team can focus on improving the product, both in hardware and software, after you ship it. But it's inherently very risky to only have one product. And so we want to move into a model where we not only just have a printer, but we have post-processing solutions. Not only just have one technology, but we can expand into SLA and SLS and expand the materials portfolio. And so you need a group of engineers that's dedicated to identifying product issues and then solving them after you've introduced it into the market. So that's where I started. Was the first person in that role full time. It wasn't super well defined, but that's okay. And sort of carved out exactly what that looked like. And it sort of breaks into, I want to say like two broad categories. There's the data side of things. And we have a number of data sources that we rely on to get a signal from our user base. So customer service feedback is a huge part of it. So when you write in a support ticket, the customer service agent, it's not only their job to get you up and running, but also to take really detailed notes on exactly how your printer might be failing or what your application is. And then we use that as a pretty strong signal for the things that we should be working on in engineering. We also have a wealth of manufacturing data. We're pretty well vertically integrated with our manufacturing lines, and so we get a wealth of information back from there. We also get information back from the printers. So when you vote on your print screen, we do use that information to put a lens on engineering activity on what we should be improving. And so we have a number of these data sources. It's very noisy, just for different reasons in each of those data pipelines. And it's our job to make sense of that data. And sort of the output of that is a prioritized list of engineering projects. And then the sustaining engineering activity, which is larger than the team itself, is to knock those out in priority order, whether those are issues that happen frequently or features that are requested frequently or issues that are severe when they happen, and then knock those out in priority order. And so when you launch a new product, the sustaining engineering activity is, again, everyone on the engineering team. And so right now, 3L is an example. The 3L design engineers did not get peeled off of the project as soon as we hit the manufacturing line. There's still a lot of work to do. And so early on in a product launch, my team is very focused on the data side of things, informing the engineering teams on these are the priorities according to our users on what we should be working on. And there's a mix of manufacturing data and all the other things that I mentioned there as well. And then over time, that design team crossfades with the sustaining engineering team. And there will be a long tail of work that needs to happen even after the design teams have moved on to whatever the next best SLA project might be. And there's a lot of core work that still needs to happen after the fact. And those can be issues that pop up as a function of the printer's age. Those can be the validation of making the printer more cost-effective to manufacture. So there's a lot of engineering activities that happen for about a year or more after a product launch. And so you need a dedicated group of people that really understand the product, really understand the signal from our user base on what's important and can execute on those two things. And so that's where we really shine.
Cool. Thanks, Jake, for the detail. I have some follow-on questions, but I want to move things around. So Caitlin, you're getting a question. So Ian, you kind of talked about, process and people. And I do want to talk, as the company's scaled up a lot more, Ian alluded to today we have 40 engineers on Fuse, which is more than we maybe had on the Form 1 team even. And Caitlin, I know you've played both the role of engineering lead and program manager. So I'm kind of curious if you could talk to, as companies grow, it can be tricky to identify when you really need these sort of new hierarchical functions like program management or product management. So can you talk to kind of what does it look like if you're a small growing hardware company, about when should you start thinking about introducing something like program management? And maybe a little on what does that mean? What is your role as a program manager versus an engineering lead?
Yeah, so program management is actually a little funny. I think we actually started using this name pretty late in the game, and actually much later than I was already doing the role. And so, which was pretty funny. We sort of like identified it as something we needed to do. And then after the fact, acknowledged that, oh, this is something that's really important to the team. And so, as Ian mentioned, we had very few people working on the earlier products. I think when I joined for Form 2, there was maybe 20 engineers at the time. And now we have something like 200 engineers, depending on how you count them. And so I think the real distinction, it becomes really important as soon as you start splitting up the engineers and having them work on multiple different products, multiple different priorities, and really needing someone who can help bridge teams and make sure we are allocating resources to the correct places. Because when we were working on the Form 2, for example, all the engineers were working on the Form 2. It was very clear what the priority was. We were all in the same room, so it made it really easy to communicate. I think we, meetings, everyone could be in the same room. You could. It was very clear what problems to focus on, who needed to talk to who. Everyone knew each other. When we started ramping up, I think to Form Wash and Form Cure, it definitely got a little bit fuzzier for who exactly was working on which team. I think that's when we started matrixing our teams and actually having some teams like optics, where optics team is going to start working on both the Form 2 and on Form 3 development, and now Fuse development. So I think it was around that time when we started needing people who could help bridge the different teams and start organizing the different programs. So as for what I actually do, it's always a good question. I think a lot of it has to do with really executing on delivery of the program. So anything it does that's required to make sure we're delivering our products, ideally on time, ideally as quickly as possible, but also making sure that we can deliver good products. So I think that's something we always pride ourselves on here at Formlabs, is we don't want to ship bad products to our customers. And so a lot of that is tracking what our engineering team is doing, making sure we're focusing on the right priorities, the highest risks, making sure we're validating everything, making sure our teams are talking so that we are making good decisions, working with our product managers, which is also a relatively new group that we started with once we started having multiple teams working in parallel, and making sure we're building the right product and making sure that we're incorporating all the right features. And then really working with the technical leads so that they can focus entirely on how to build the best product and making sure that they're focused on solving the technical challenges and aren't so bogged down in things like resource management, and making sure that we have enough software engineers, enough mechanical engineers, we have the right space, we're delivering according to the timeline that we've set out for ourselves. I think when Ian can probably speak to this too, when Ian was working on and leading the Form 2, he was doing it all. He was doing people management, program management, and the technical leading for it. And I think as soon as we started branching out to multiple products, it became clear that we started needing people who could focus on each one of those.
Awesome. Yeah, that makes a ton of sense. And if it's not surprising, it's a bit of a theme at Formlabs that people take on multiple roles before we figure out we need to split it into 3 jobs. So definitely keeps us on our toes. Cool. All right. Shifting over a little bit, we've talked a little bit about how, it was easier for decisions to get made when we were all engineers in a room together. So I wanted, nice throwback pic, when we were all in person on a lovely stage at the Media Lab a few years ago from Diana. I want to talk about being together. So Formlabs really does kind of believe it's important to be co-located for physical product development. However, we are a global team, and there's been a really nice sort of global tour where we've taken people around Formlabs North Carolina. We have our software engineering office in Budapest now. As part of the user summit, people had a chance to go and see those locations. So I'm going to throw this one to Ian, but I think any of you can really answer. What's been the rationale in kind of moving some of our engineering to other locations? I don't know if you can talk to that.
Yeah. So yeah, as we've grown, just to sort of reiterate, we've been expanding our engineering efforts tremendously over the years. So we're actually over 200 engineers, which is sort of sometimes mind-boggling to me. But it is really great when we actually need to work on really hard challenges to have all these great talented engineers to work on these problems. So as we've been growing, we've identified different areas where we need we need more engineers. One example was basically in our software development, and so I think many people in the engineering world may understand that hiring software developers is very competitive these days and can be very challenging. In the Boston, Cambridge area, it's as competitive as anywhere. We're competing with Googles and Facebooks and things like that to go and hire the best software developers we can. Certainly we work on different types of products, and so there are those engineers who are just drawn to hardware development, don't want to just write code, but also want to get their hands on stuff. And Formlabs is a great draw for those people. But sometimes we still need more people, and so that drew us to Budapest in Hungary, where we had already been doing manufacturing and had some other roots due to some employees at the company. So we started looking into who we could hire in that region, and it turns out there's like a kind of a vast reserve of really talented software developers there. And so software development, unlike hardware, it's easier to do remote. Certainly, we're still constantly shipping hardware back and forth, but it is easier for us to connect, and a software developer in Hungary can SSH into one of our printers here at HQ and start debugging things remotely and have that conversation going from halfway around the world, which is super cool. So we've been growing our team there, and that's really enabled us to grow the software team much faster and with much better talent, which was a really big challenge for us to grow right here locally in Boston. And then we also have a relatively new office now. It's not new anymore, but in North Carolina. And this was a similar situation that we slowly started developing some roots. We'd already hired 2 remote employees in the region, and another key employee was moving to the region, and we thought the sort of technology triangle in North Carolina is a really place full of talent. So let's spin up an office. We can start recruiting talent there. We are now big enough that there are projects that we can hand off to a team that has the right talent in a spot, and it's let us tap into a very different pool. In the Boston, Cambridge area, we have lots of access to super talented graduates coming right out of, say, MIT, like Caitlin and Jenny. But we actually, for various reasons, it's been hard for us to maybe develop all the different types of skills and experience levels that we've wanted on our teams. And having access to a very different market enabled us to start growing the team in different ways. So the North Carolina office has been steadily growing. It has some super great talent, and they tackle all sorts of interesting R&D and systems problems that get fed back into products right now up at HQ. And it's been a really interesting experience working with a remote team, but also in the last few months we've kind of all learned to work remotely, and so this is transitioned into sort of like normal day-to-day, no matter where somebody is.
Great segue. I was going to do the same thing myself. So, so yeah, ideally with hardware, I think, it's nice to be co-located. You're all working on physical objects and you want to kind of see them together. So obviously, real spanner in the works this year with the obvious global pandemic. And double whammy, we're also pretty ambitiously trying to ramp up Fuse 1 and Form 3L production this year. So Caitlin and Ian, can you talk to, I guess, take one question each. We'll go to Caitlin first, but I'd love to kind of cover both just trying to do hardware development remotely, as well as specifically kind of ramping up production, obviously working with our factories overseas.
Yeah, so COVID definitely hit us at definitely the worst possible time, I'd say, for the Form 3L program. We were just getting ready to start building our next prototype cycle before heading to the factory. And it really messed up our supply chain. It made it really, really difficult to get parts because it was affecting a lot of our vendors before it was affecting us here in the US. And so it delayed getting parts in. We were definitely dealing with that and trying to do a bunch of mitigation with ordering parts locally and trying to see what we could make up and do there. We fortunately were able to get a little bit ahead of it before it really shut down in the Boston area. And so we were able to kind of rush the build of some of our early prototypes. We had a lot of really late nights. The team worked extremely hard knowing that there was a chance that we were going to be shut down. And so we were able to crank out a couple prototypes. And then the nice thing about having these somewhat portable 3D printers is we were able to send them home with people. And so we actually organized this fleet of U-Haul trucks where we gathered up a bunch of the prototypes and sent them home with a couple of our key engineers so they could continue doing development on those and validating those prototypes from their homes. And it's certainly a little bit easier to send the Form 2s and Form 3s with people. And I think some people did take those to do some in-house prototyping. The Form 3Ls aren't quite portable. They definitely take two people to lift them. They don't fit in your standard sedan. But we were at least able to get them home to people. I think the worst one was taking it up 4 flights of stairs in an apartment that had no elevator. I think we haven't actually retrieved that one because no one wants to take it down. So, but yeah, it was definitely something that we quickly were able to do, and I think that really helped us get more work done, especially during the worst of it here in Boston when the office, we didn't have access to the office and people had to do a lot of their work remotely. Later on, once things started getting a little bit better and we started having people come in, we had to reorganize our space to make sure that we had the capacity limits in place for a number of people in a given suite. There's like a ton, the whole office, our entire operations team of the office really did a great job, like totally rearranging everything and really making it safe for us to come back. As for, I'd say the next few months after that, we did a lot of like rotating schedules. So when people could, they would do work from home, especially a lot of things like communicating with our vendors and doing like analysis and stuff. They could do that on their computer at home. But of course, we were in this time when we were being very hands-on with the prototypes and wanting to see them. And especially as they're starting to come in from our contract manufacturer, we really wanted to get our hands on the printers. And for that, we'd have to set up some rotating schedules. But overall, I think, like Ian mentioned, because we have the ability to have engineers in multiple places, if we had software engineers, they could stay entirely remotely and still interact with the printers through SSH. So it was mainly I would say the hardware engineers who had to come in and really get their hands on the printers. Yeah, I don't know. Oh, I guess one more thing is that we also really started using a lot of video calls, so a lot of video debugging. So I think we set up a webcam in our build space so that people would have easy access if they needed to like call another engineer and say like, hey, help me debug this issue I'm having. So yeah, definitely doing a lot of video chatting.
Yeah, I was super impressed. There was sort of multiple views, 24-hour live webcams with the factory. That was pretty cool. Were there any things that we kind of ended up doing just as creative problem solving you think we'll probably keep up?
Yeah. So I guess segueing into the factory, how we ramped up at the factory, as Jenny mentioned, we were doing a lot of remote debugging with our factory. And because we weren't able to send anyone there, normally we send a rotating crew of people. There's always like 2 or 3 people there at a given time during product ramp up. This time we weren't able to have anyone except for the couple engineers that we have based near the factory. And so we had to rely very heavily on remote debugging. We actually had a lot of engineers switch their schedules to be either very, very late or very, very early. So we actually had a shift that ran until midnight. We had a shift that ran and started at 4 a.m. And then we actually had a couple brave engineers who volunteered to flip entirely nocturnal and actually work through the night so that they could be support for the engineers, the couple engineers we had based at our factory. And I think that all really, really helped us not need to be dependent on having engineers who were at the location of production. Given the choice, we'd still send, if COVID didn't exist, we would definitely still send some people. But I think the big takeaway from that is that maybe we don't have to send nearly as many, which would definitely be more cost effective and a little bit easier on people's schedules and flexibility. And so we did do some more creative use of video calls where we would have like 3 different setups on 3 different areas of the line, communicating with our factory, where we'd be watching them go through calibrations or watching them go through assembly and really catching any issues early on instead of waiting for them to find the issues and then responding to them. So I think that doing that really helped. We definitely invested in better cameras, better webcams, better speakers, stuff like that.
Cool. Thanks, Caitlin. All right. Just some people might be jumping in late. Thank you for your questions. I'm keeping an eye on them and I'm going to pepper them in soon. But one more question for Jake, and this is jumping around a little bit. So yeah, you kind of explained what you do and that we're just constantly learning from printers in the field. So one thing I think is definitely very cool about Formlabs products is that, sorry for the cheesy analogy, but like a fine wine, they get better with time because we're always adding new materials. We introduce a lot of improvements through software, through speed up and things like that, which I think is good, but it's also not the norm. There's also this sort of, even internally, there's a school of thought about, we should wait until everything's perfect before we ship the product. I'm just curious, what's the mood in the industry? Like we do sustaining engineering at Formlabs, and that's like kind of important to us that we do improve our products even after they've shipped. But is this like a trend? Are most companies doing this? Is it like a ethos thing? Yeah, I'm not sure if you have a point of view on that.
Yeah, this is quite a bit more common in software, like you mentioned. You sort of just release it, see what breaks, and then fix it over there. We have the advantage of being able to do that with our printers a lot of the time. The other reason that we sort of take this approach is that we actually do believe the printers are going to get better over time, both from features and from materials. And so this is going to be like a big circle explanation here, but you can approach sustaining engineering in 2 ways, or it's along a continuum, and I'll sort of describe the ends of the continuum. One way is that you can have the design engineers own their designs for life. This is sort of the traditional paradigm that you design a system, that system stays in the field for 10 years, 20 years, whatever, and you're responsible for maintaining that system over time. And you get 2 big things from that. You get a lot of things, but the 2 big things are that people really only release things when they are absolutely perfect, potentially even to a fault, where they are over-testing, over-validating, and doing things that are really unnecessary or sort of low risk. And the second thing that you get is really good documentation, because people know if they have to fix something in 2 years, they're going to have to read their own stuff. And so there are some advantages to that. Things tend to be really, really stable when you launch them, but product development tends to be really slow. And so the other end of the continuum is that you can have a really strong sustaining engineering group, and the design engineers can really, really rapidly release their hardware, software, and materials. And then as soon as they're available, they can move on to the next technology and the next iteration of that product. And that's the approach that we adopt. And like I mentioned before, it is a crossfade, so we're not fully on that end of the continuum. And certainly when really complex parts of our printers break, the design engineers come back either in an advisory role or come back to fix the system fundamentally. But the the other thing that I want to mention, there was a question in the Q&A here. And the question is, what is the future of 3D printing? And I think the question is for all four of us, but I'll take a stab. So hardware product development is inherently a step function. When we release a new printer like the Form 3, you go immediately up from the Form 2 to the Form 3, and then that has to be set in stone in some capacity. If you buy a printer in January, you need it to be the same printer as the printer that you buy in September. So you have to make a step function in your hardware products, but the materials can release for a long time after you do a hardware product release. And that's really where the evolution of 3D printing comes in, because we've been developing the Form 3 for a number of years, and it's now really stable, and we have tons of them in the field. We also have tons of them in the hands of our material scientists here at Formlabs, and they're still discovering the limits of that technology and how capable that hardware platform is. And so the resins that we're going to release for the Form 3 in a year just wouldn't have been possible to develop before the Form 3 released. Same is true for the Form 2. There are resins that we released towards the end of Form 2 production that simply wouldn't have been possible to develop at all pre-Form 2 launch. And so you get this gradual evolution of the printer and the ecosystem over time. Even if the printers themselves are a step function, we're still unlocking the limitations of those machines.
Cool. And yeah, so we'll answer this one live. So also, Caitlin and Ian, if you have thoughts, the question was phrased as, what do you see as the next stage in the evolution of 3D printers? Like, what's the most important next milestone? Is it size? Is it speed? Any sort of themes of what we need to address as an industry?
Yeah. I can jump in here. I think this is obviously a very broad question, and I think you ask 10 people, you might get slightly different variations on the answer here. I think at Formlabs, we're very focused on accessibility and cost, especially like cost per part, and over the course of a life of a product. So we still see that there's lots and lots of ground to be made in both of these areas. There is still work. I mean, we're constantly trying to improve the user experience of our products to make it easier for a wider range of people to actually get their hands on 3D printing and use the technology to do applications that otherwise wouldn't be possible. An example of this is that we now spend a lot of time working with dentists, and a dentist is not an engineer. They have a different skill set that they bring to the table, and so we need to build a product that actually works for a dentist, which is a step beyond what 3D printers originally were designed for. An engineer is used to working with technical equipment, and certainly, dentists actually do have a surprising array of technical equipment in their office. Their skill set is very different, and so that's where we, every time we make a step forward in accessibility, we open up new use cases, new users, and enable it to go for new applications. And then the other big place is in cost and cost per part. So by really pushing the overall sort of cost of our products, we can enable new applications. And so the further down we can get this on a cost per part basis, while still obviously keeping performance and material properties and things like that enable these applications, we're enabling people to do new things. And so this lets you do more manufacturing, makes it easier to use 3D printers in your development process, whatever that process is, if you're designing mechanical parts or if you're doing artistic projects for the entertainment industry. Lowering this cost per part lets you actually use the products more, and by using the products more, you actually evolve your development process. So I still think these are super important focuses for us. Some of these things we'll see step changes, and some of these we'll see constant evolution and pushes, very Moore's Law style. And I think, sometimes you'll get a Form 3 and sometimes you'll get a gray V5 resin or something like that. Each of these things are chipping away at this problem and getting us closer to where we want to be in both these areas.
Cool. And I'll jump in with a much more high-level answer. I think Formlabs is sort of secret sauce is taking these really capable high-end technologies and making them accessible, which for us is sort of the right quality at the right price point, with the sort of the magic of also being easy to use, and that breeds like a step change in how many printers are out there, how many people have access to this technology. So I think the next evolution is continuing to apply that to new systems, and we're living and breathing that with some information which is public in terms of like large format SLA. The Form 3L is super exciting. I think that's really going to make large parts, high volume printing much more of a reality for a lot of people. And then also with the Fuse 1. So I think that sort of accessibility to other 3D printing technologies is a trend that's only going to continue. And I'm excited to see it, from Formlabs and hopefully from other companies as well, just continuing to make access to technology more of a reality. We're going to continue to do it through materials as well. So that's a trend you can kind of keep an eye on. Cool. All right. Sorry, Caitlin. I'm just going to keep it moving, but you can jump in on this next one. So Stephen Curran asks sort of two-part question. First part, and this came up in Max's AMA as well, how often do parts for new product designs and prototypes end up being printed on Formlabs printers? I'm not sure how to interpret this, whether it's internally, how much are we prototyping, or in general, how many parts in the world are being prototyped. I think it would be a lot. And the second part to that question, how many parts in final products end up as 3D printed parts? I assume this is internal facing, because that's kind of what we're talking about. So let's answer this in terms of at Formlabs.
Yeah, so as someone who did a lot of early prototyping for Form 2 and Form Wash and Form Cure, tons. We rely very heavily on the printers that we have. We have a lot in the office. So with Form 2, very heavily prototyped on the Form 1. Form 3, heavily prototyped on the Form 2. You get the idea. So I like to say that the better we make our products, the more products we make, the better our product development process gets, because it gives us a bigger and bigger advantage. So now that we have the Form 3L, we have a bunch of them in the office, it makes it a whole lot easier to prototype parts that are much bigger. I think when I was prototyping parts for the Form Wash, or rather Form Cure, I think every single part would have printed on the Form 3L if we had access to it back then, but we didn't. So instead, there was a whole lot of like chopping parts up, gluing them together, sanding them down, which was way less efficient and was way more painful. We've actually done a lot of cross-pollination between our teams. So we've printed a whole lot of parts for the Fuse and SIFT teams. We've also had them print us a bunch of parts for our machines and prototypes, depending on what material properties we need or the size needs. So there's definitely been a ton of prototyping done internally. Sometimes it's too easy. Sometimes people will prototype things on these 3D printers and we look at them and say, you should have just laser cut that, or you should have just machined it. It would have been way faster. But I think people have it's gotten too easy to print things when we have access to a lot of 3D printers around here. As far as how often they end up in the machines themselves, I would say starting with the Form Wash and Form Cure, I think we did start putting some 3D printed parts into those, maybe like one each, just as an Easter egg. And then for the Form 3L, we were looking to see which parts made sense to 3D print. And there is actually one part, I think it's just one part in the Form 3L that is 3D printed on our machines. And I think a lot of it comes down to volume. So whether it makes sense and whether it's cost effective, because in the end, it's really hard to beat injection molding prices. So for lower volume products, I think it makes more sense to have something that's 3D printed on there. And then, of course, as we ramp up with making it easier to have these factory solutions and all these different improvements to our printers, I think it will make it more cost effective to use 3D printing in the future. But in the end, it is hard to beat injection molding costs. So I would say a couple, and I think Fuse actually might have some more, so Ian can speak to those.
Yeah. I was gonna jump in and say actually, Fuse is pretty fun in that we've actually been using a fair number of parts printed on the Fuse, as well as SLA parts. But for shipping, we have about 6 or 7 parts that are 3D printed right now. But through this sort of later stage of manufacturing ramp up, we've actually had between 20 and 30 parts that have been printed during most of this time while we've been waiting for some of our injection molding tooling to come online. And that lets us do that. And then the parts that we are leaving are kind of neat because they're hard to injection mold, or the design work would have actually taken us a lot of time and caused us to overhaul things in ways that would have affected the timeline. So we have a part that is it actually has a unique airflow channel, and it's a very organic shape. And this shape would actually have been quite hard to injection mold. All of our engineers want to try to, work on that design challenge, but actually we just save ourselves months of work and headaches trying to go through figuring out how to tool that part by just 3D printing it, which is great. So we're busy manufacturing lots of parts for our printers right now on our printers. And this also gives us the second benefit of really battle testing our printers like customers. So we have printers running 24/7, churning out parts for this application. And then there's also one other fun sort of like dog fooding point, which was during Fuse. I don't know if anybody here has used the high temp resin, but the sort of design spec for high temp, lots of people wrote down different things, but really the design spec was, will it work inside a Fuse printer in our hot chamber to allow us to prototype and move faster. And so we were our very first customers of our high temp resin, creating all sorts of fittings and mechanical parts inside our heated build volume inside Fuse. And so that resin has been evolving based on our sort of internal user feedback, as well as outside users. But having that sort of quick loop where they could create a new formulation, we could print it out, put it on a printer, and see how it actually holds up in real use was really cool.
Cool, thanks both. So yeah. Daniel thinks printers are cooler than laser cutters, which I feel could be worth a poll. Laser cutters are pretty cool too. We love all fabrication tools here at Formlabs. But yeah, it is testament to how easy to use they are. I think we have a advantage that everyone gets trained on Formlabs technology. But yeah, basically is a free for all. If you work at Formlabs, you got access to these printers, which is great. I think it's one of our official perks is access to unlimited 3D printing.
Still in the offer letters. Still in the offer letters.
Hey, it's yours if you join the team. Cool. Okay, so Ian, you got two lengthier questions addressed to you. So I wanted to maybe just say, have you read them, and would you like to take one rather than me read them?
Yeah. So the question from Brian, just to summarize, is how did we find our manufacturing partners for our product development, especially as when we were a smaller company, and and where our products made stateside or overseas. So at Formlabs, I've had the fun, if not a little bit challenging experience of constantly moving where we're manufacturing things as we've grown. So our needs for manufacturing have been vastly different for each generation of Form printers. So the Form 1 was made stateside, and then the Form 2 printer was actually made in Europe, in Hungary, and now we build the Form 3 in Asia. And so got into see some of the pros and cons, although the challenges at different volumes have certainly added their own flavor to each of these product development processes. So finding manufacturing partners, this is a very hard process. It's not like there's not a lot of things you do as in the product development process that's like picking a contract manufacturer or manufacturing partner. It is a partnership. You're both interviewing somebody, they're selling you, you're negotiating pricing. There's a lot of roles and responsibilities that you have to negotiate with a different company. And so this is it's really hard. These are some of our most challenging external relationships, and also obviously some of the most valuable ones. When you get a contract manufacturer up and running, it's a really amazing thing where, at some point, we, with very minimal involvement, we can basically, in some ways, click buy and get hundreds of 3D printers shipped to our warehouses and distributed to customers. But it requires an enormous amount of effort to do that. So the biggest things to do when you're looking for a partner, just as some quick pieces of advice, is find companies that have built products like what you're building. Look for people who are really going to, basically provide the value that you need. I think a lot of contract manufacturer partnerships offer a lot of engineering support, but really at Formlabs, we have really talented engineers. What we need are people who are really manufacturers. They need to have strong supply chain skills. They need to have strong manufacturing teams to actually do the assembly, and they need really good quality control. And then the last thing contract manufacturers provide, which is kind of like a hidden nugget in all this, is actually they're kind of banks, and they actually go and actually buy all the product and kind of front the money to build the products. So you find a partner who's financially sound and can meet your needs. So all these things are key things we look for. Beyond that, there's lots of important cultural and like team fit aspects that are always the case whenever you work with anybody. But yeah, this is really hard. There's no one right answer. But maybe one last piece of advice is keep it simpler. If you have a great partner local, that's really a great place to start. And then if you really need cost, you know if you need that, and there's only a few ways to get the cost that you really need, which is going to lower cost manufacturing regions. So
awesome.
Yeah,
Thanks,
love
Ian.
geeking out about product.
All right, and there's one more question, and it's maybe a tougher one to answer, but I feel I want to address it and not ignore it. So, question about how much does sustainability and renewable materials and material sources play into designing hardware for Formlabs? And rather than pun this to someone, I'll take a stab at answering it, and please feel free to weigh in and elaborate on my answer. So, I think sustainable materials, renewable materials, it's not the top of mind. It's not the first thing we go after when we're picking materials for our hardware. We are making lower cost machines, and so sort of we're looking for readily available materials we can source from multiple vendors. Another big consideration for us is chemical compatibility of materials. So they need to be resin proof. That's one thing that I remember in the early days seeing different material samples like sitting in a cup of resin just to make sure that they would behave well. I think like the early Form 1 cover was made of acrylic. We eventually moved to polycarbonate and things like that. So just to say there's definitely some factors that I think come first in terms of can it go into a Formlabs system. And then, yeah, I'm not sure where and if it does come up. Maybe Caitlin and Ian can elaborate.
Yeah, I'd say like Jenny mentioned, I think we are dealing with a lot of challenges. So I think we are mostly focused on function first and making sure that we can, make these printers work and perform as well as they can. But that doesn't mean that we aren't ignoring this. I think a lot of us here find sustainability really important and want to do what we can whenever possible, especially if there's an easy trade-off. So I know one of my personal favorites is that for the Form 3L tank storage cases. So it's the case that your resin tank will come in the Form 3 that comes in a plastic box. And we were considering something similar for the Form 3L just because it was the easy option and kind of the default. But after taking a look at it and really thinking about it, I'm really happy that we ended up with more of a chipboard design so that it isn't quite as plastic intensive. And I think that is something that I at least appreciate, and I know a lot of other people on the team appreciate. So I think whenever possible, if there's an easy trade-off that doesn't affect function, we'll do it. But we are also really, concerned with making sure the printers perform as well as they can, which sometimes requires using these less sustainable materials. Jake, cool. I don't know if you have any thoughts or Ian.
Yeah, I can definitely echo all of that. We definitely get this signal from our user base that this is important. I think people are making plastic parts, and we do try to cut down on waste on product development in general by reducing the number of tools that you need to cut and things like that. But this is something that our users care about, and we're definitely looking into different options. I think in terms of the development of the printer, the easy one to address, especially after we start shipping these products, is packaging. And we actually have a number of open projects open right now to reduce some of our waste in packaging. And some of those, it's really tough to identify exactly what's going to work, especially with something as weird like packaging. So for the Form 3, we're actually exploring changes to the foam, and I'll sort of give a little bit of a sneak peek to some of the stuff we're working on. But exploring some changes to the foam. We've looked at lower density foams in the past. But what can end up happening if you have a marginal system is that you can tweak one of the knobs like density, and then you do your drop testing and you realize, okay, 1 out of 10 printers will have their shell cracked when exposed to this edge case scenario. And maybe that this scenario doesn't happen all the time, but then you have a certain partner in a certain region and a whole pallet of printers goes down. And you have to return those printers to either where they're going to be repaired or to the country of origin. And so that produces a ton of waste in shipping printers around, whether that's by sea or by air. And so the cost equation doesn't work out in terms of environmental costs. It's not as straightforward as you would think. So you need to make sure that the material works for your application, whether that's the function of the printer or the packaging. And so we have a number of open projects. Cartridges are where we're focusing our attention right now in cartridge packaging. I have a couple engineers on the team right now that are looking into some changes that would reduce our footprint there. The other big one that people like to point to is the cartridge recycling. I think this is an easy one to point to and say, like, hey, why don't we recycle these cartridges? This actually is a pretty difficult problem if you don't have a distributed network of like local solutions to cleaning and recycling those cartridges. If you need to ship each cartridge back individually to some centralized location, like we'll take Boston as an example, the carbon footprint actually doesn't work out to do something like that. And so you need something a little bit more local, and that becomes really difficult to do for our global user base. And so I think if we looked into something like that in the future, and obviously don't want to make any promises, but if we did, it would be something like a distributor network where you could send something to someone local. But in order to incentivize that through a partner, you need a sufficient volume. And so this is something that we have looked at in the past, and we're definitely listening, but we want to make sure that the cost equation works out, both like cost to the users, cost to us, and the environmental footprint equation needs to make sense.
Cool, thanks, Jake. I didn't think we'd end up talking about packaging, but here we are. And yeah, we definitely throwback reference on the Form 1. We had this very cool, innovative packaging, which was pretty sustainable, I think, where it was sort of a clear trampoline that the printer was suspended, and it was very low material, but our printer was really edge case in terms of what that type of packaging could protect during shipping. And so we did eventually move to foam, even though that was pretty cool. So I would say it's a variable that we consider alongside other things, but definitely our sort of mission to deliver a high quality, reliable experience where your printer arrives intact, et cetera, is kind of is top of mind. So cool. We're kind of on the hour. So there's one more question from Levi to Jake. Jake, maybe you can hang around in the chat and just answer that, but I want to be mindful of people's time. So thank you all for your time today. This has been really fun. Miss your faces. We'll hope to see you in person soon. And thank you everyone who joined and those who took part in the questions. So yeah, I hope you're enjoying User Summit, and I think we're all sticking around. You can click on our profiles and message us and all that good stuff. So if you didn't get your questions answered today, please reach out. Otherwise, enjoy the summit, and I'll be hanging out in the next event. See you there. All right. Bye, everyone.